Right. Good morning, good afternoon, good evening to everyone in ISCT watching us around the world. We are coming to you from the ISCT regional meeting, North America regional meeting here in Houston, Texas. And I have the pleasure today to be filming with one of our early stage professionals, abstract award winner, Devin McAvoy. Welcome.
Thank you. Thank you.
How have you been enjoying the meeting so far?
Oh, it's been wonderful.
Yeah. You've gotten to meet a lot of people?
Oh, yeah.
Network? That's good. Sure. Awesome. Well, you guys have a large contingent here, I think.
Yeah.
MSK.
Yeah. Since Dr. Boland is one of the chairs, he has recruited many of our MSK colleagues to be here, it seems like.
Well, fantastic. All right. Well, let's get started. Please tell our members a little bit more about yourself, your current role at MSK, and if this is your first ISCT meeting or if you've been involved a while.
Sure. So I am a research laboratory manager at Memorial Sloan Kettering. Our lab is the Immune Discovery and Modeling Service. And our function is primarily immune monitoring for patients after they receive a bone marrow transplant. My role has been very varied over my course of employment here. When we started about 3 years ago, it was just my boss and I.
Okay.
And so we were doing everything, all the bench work and the project management, data analysis, all of that. As we've grown and specialized, my role has been steadily shifting towards data analysis specifically, and working on building up a lot more bioinformatic capabilities. So we have so much data and can only analyze it so fast manually. So I've been working on developing computational methods as best we can. And we're formalizing all of that in the near future.
That's awesome. It's like a lot of data to process. It's not a bad problem to have, but when you have, it's nice that your lab has the expertise in you to make that happen.
Yeah,
that's
time
awesome.
is the limiting factor for everything.
I hear you. Okay. Well, that's amazing. I bet you got a lot out of were you in the how your lab can grow sustainably session?
Might not have been
that one, but that's been a big theme of the meeting is how you can grow a lab from very few people. Sounds like you were employee one of that lab to something where, you have multiple lines of processing, so many different therapies being made, different people coming in, positions getting more specialized. It sounds like you guys are on that same kind of trajectory. So, oh, very cool. Very cool. All right. So as part of your award, you are giving an oral presentation on your work entitled, and I'm going to get this right. I'm going to read it straight. Predictors for recent thymic emigrant T-cell reconstitution after hematopoietic cell transplantation. Super cool. I admit I don't know a lot about that at all. So I'm very excited to hear more. But tell us how you came to get involved in this work. What was the genesis for this idea?
Sure. So like I said, we are an immune monitoring lab. It's our primary function. We take lots of other projects because we're equipped for them. But primarily, Dr. Boland is like this brainchild of get immune monitoring started at MSK. So primarily, I think his interest that drove us to add recent thymic immigrant monitoring to the program. He knows it's a very important and sort of understudied cell type. So as we've accumulated data from our immune monitoring program, that was a high priority cell type to be analyzing. A lot of the other data we have has been studied before, your usual CD4, CD8 T cells, the subsets. And, those are interesting. We see, you can always find new things when you're looking. But the RTEs, I think, is a very new field to be looking at. Yeah.
Oh, I would say so. I had not heard of them until today, or when I was preparing to talk with you, and read your abstract and your talk. So I admit my own ignorance around this idea. So I'm curious. My first question about it when I was looking for your talk and your abstract was, are RTEs more of a population of interest in younger HCT transplant patients or older? Because my little knowledge that I do have, I thought the thymus is more important for younger populations. Like it becomes less important as you get older, but maybe that's not the case.
So that is true. In just healthy patients, healthy donors, you'll see much higher RTE populations in younger people. It's, so RTEs are intermediate development T cells where they've exited the thymus. They're not matured into T cell as of yet, right? So for younger people who are still, developing their immune system, it's a much more robust population. As you get older, you sort of have your immune system established, and there's not as many new T cells being created. And in the context of transplant, we really only study pediatrics at this point. Our immune monitoring program is for the pediatric service, but we have, the pediatric service does cover young adults, so a certain number of people over 18, and we do see just lower levels across the board in those patients. As far as how important it is, it should be important for all of them. After you've been through your conditioning regimen, you do not have an immune system anymore. It is important that your thymus will replenish it and
Makes sense.
Continue to regulate your immune system and just leave it to the donor cells forever. Yep.
Well, that sounds like such a unique data set that you guys have now, like over differing ages. Pediatrics is like none other specialty where, I mean, it covers so many different ages.
Right.
You can hardly lump a 5-year-old in with an 18-year-old,
Right.
right? So I'm excited that you're getting that information and how much we'll learn from just capturing that one piece of immunity reconstitution for sure. One thing I wanted to bring up and point out to our audience, you mentioned an interesting connection that you saw between RTE reconstitution and GVHD occurrence. So I was wondering if you could speak a little bit more about that and maybe give us any hypothesis or maybe some causal connections that you guys might be figuring out as to where that connection comes from.
Sure. So, there's sort of the obvious where, GVHD is systemic and your donor cells are going to be attacking your organs throughout, depending on the severity. But it does seem that thymus tends to be hit. And
so I had to come by.
So what's the connection between GVHD? So if it's attacking the host, is that somehow preventing these RTEs from?
Sorry, I'm back.
No, yeah.
I don't think.
Right. So the donor cells are attacking the thymus, and thymic damage. There's a decent amount of literature out there. Once your thymus is damaged, not necessarily by GVHD, that can result in immunodeficiency because you're not.
So did Chandler go?
So that's fairly
So did
well
Chandler
studied.
go or what?
But not particularly in this context.
Okay.
Wow.
And from what I could see, not as much with sort of RTEs as the
well, they
indicator
came back
for if the thymus has been damaged. It's sort of, we already know that the thymus is damaged, so how is that affecting things? And by monitoring RTEs, you can establish for yourself, like, okay, was there thymic damage after this transplant, and how is that going to affect everything else?
Okay.
So
So
what
when you
time
take these
we're-
measurements, are you adding that into the normal monitoring repertoire of these patients, or do they have to come in for additional touch point procedure?
No, this is part of the normal monitoring. We actually started out as a research test for this, and it's We have a massive immunophenotyping panel, T cell specific one. This is all by flow cytometry. So it's really high density information in that panel. And that's for research data only. And we apply that at specific time points in the monitor, of course. But we also did sort of develop and validate a clinical RTE test by flow cytometry. Handed that off to our clinical immunology lab that we work very closely with, and it has been CLIA approved for a while now. So they monitor more time points than we do with the big T cell panel.
Okay.
So we actually get more time points for the RTE measurements as well. And yeah, it makes it a lot easier to collect that data.
Okay, so you're amassing all this data. Clearly, it's already showing like clinically relevant findings. So like what you have talked about here for sure is already has the potential to significantly influence transplant patient care and even like the course of someone's treatment potentially, right? So like how do you guys plan to take these findings forward into the future?
Yeah, so there's definitely some clinically actionable things you can take from monitoring RTEs, separate from overall T cell reconstitution, which can be attributed either to your existing T cells expanding or the creation of new T cells. This lets you know that the thymus is back online and is regulating the immune system. So, you don't want to necessarily take your patients off of immunosuppressants until the thymus is back to full capacity of what it can do. So that it does give us, a little more nuanced view of the immune system and when it's time to make those clinical decisions.
I figured more information is good information.
Yeah,
right?
of course. And then also, it can inform, if you're not seeing the thymic reconstitution happen, and maybe they do achieve T cell reconstitution, but it is from their existing T cells from the transplant. But you still want the thymus to be functional. So that's when it could inform, you may want to give a pro-thymocyte infusion. We have a open-label trial that involves pro-thymocyte infusions as well.
Does this come from a donor or like autologous?
I actually don't.
That's the first I'm hearing of this. So that's very cool. Interesting. All right, I'll have to read up more about that. Homework, everyone.
I'm not sure how public all of that information is. So
okay.
Probably public, but I'll just be safe.
Okay.
Not name names.
Okay. Then maybe at the next meeting we can expect to hear a follow-up on that.
Somebody presents on it.
Okay. Fair enough. Fair enough. Okay. Well, that's cool. You heard it here first. So can you let everyone know where they can connect with you? Maybe some people weren't able to make the meeting and they would like to hear more about your work over at MSK. Where could people get in touch?
Sure. So, you can reach me by email, which is mcavoyd@mskcc.org. And you can also find myself and the rest of my lab on our lab website. It's IDMS at MSK, should come up in Google. I believe it's public. Yeah, it's a public facing website.
It'll now be the top hit on Google.
Yeah, you'll see my picture, you'll see Dr. Bolins, you'll see Kinga, my boss, and summary of all of our services. We do, we predominantly work within MSK, but we take outside projects as well. So there's lots of stuff we are capable of, and we're always looking for more collaborations.
Great. Well, hopefully you can have more of those discussions. I should let you go. We're putting off our networking to do this interview. So we have the networking reception waiting for us now, but so thank you for taking time
Thank you.
after you're receiving your award to speak with me and share your work with all of our members, especially those who couldn't be here at the conference. And I will talk to you all soon.